Hi everyone. So I think I should make some videos on this is trigonometry from just some very basic about trigonometric things, how this trigonometry works, very basic things, so that my days is a bit fruitful. This is the so this is a bit funny because the entire day I did almost nothing. So this is the thing. Oh, I actually not nothing. Actually, I watched a lot of stuff, and um, yeah, this was good. It's a holiday here. It's a holiday here. Yeah. So let's talk about the trigonometry and trigonometry. M-A-T-R-Y, trigonometry. So trigonometry, this word actually comes from, you if you break it down, this tri, then gono, then metry. So we have three different words, three different things here linked together, and we have got this word. So and so this trigonometry, tri means three, gono means sides, and metry means measurement. So three sides measurement, and you already know three sides. Which figure we have that has three sides? You have two sides, then another side, three sides. So what is that figure that we have three sides? That is triangle, right? Triangle has these three sides. And trigonometry actually works with the right angle triangle. If you draw a right angle triangle, trigonometry can work with that. If one angle of a triangle is 90 degree, then we call it right angle triangle. So this is a right angle triangle because this is 90 degree, and always the opposite side of the right angle triangle is called the hypotenuse. This is the hypotenuse, and hypotenuse is always the longest side of a right angle triangle, always. So in the trigonometry we have a couple of trigonometric ratios, and basically what trigonometry. Oh, it's a lot of wind outside, so there is a sound, so rain may come tonight. This will be interesting. Anyway, lots of noise outside. Okay, so this will be interesting. I mean, the night will be interesting. This is also interesting. What is these things? Let me explain this to you. For example, if I say in this triangle, this side is 3, and let's say this side is 4, although it do not looks like that. So let's say the length of this side is 3. You can say 3 centimeter or kind of this. So this is then 4 centimeter, and this is then it becomes 5 centimeter because of the formula given by the Pythagoras. The Pythagoras formula says this side is square plus this side is square will be equals to the other side's hypotenuse is square. Okay, so this is, if you calculate it, this side is 25, and if you calculate this side also 25. This is how this 5 comes here. So this is Pythagoras theorem, and actually always in the right angle triangle you can use the Pythagoras theorem. Now let's say you have some angle given here. This is the given angle. Let's say this is the theta. So if this is theta, then we can actually discuss the trigonometric ratios by sine theta, cos theta, and tan theta. Actually they have their inverse as well, and opposite as well. So not the opposite, actually it should be one over these things, which is inverse. Anyway, so sine theta equals to what is this sine theta? Okay, let me first tell you what is this sine theta, cos theta, tan theta, what these things do. And they are actually the ratio of the length of sides. If you write 4 divided by 3, this is a ratio. 3 divided by 5, this is something. 5 divided by 3, this is some other things. So all of these things is actually given by this sine, cos, tan, cosec, sec, cot, these things. And sine theta, cos theta, tan theta, actually if you go back and think about the old school format, then you will remember this. So ka, toa, SOHCAHTOA. So SOHCAHTOA is a very interesting and very useful mnemonic to keep the track of this sin theta, cos theta, and tan theta, because SOHCAHTOA actually works there. SOHCAHTOA means sin theta equals to opposite by hypotenuse, cos theta equals to adjacent by hypotenuse, and tan theta equals to opposite by adjacent. So this side is the adjacent side, this side is the adjacent side, and this side is the opposite side. Why they are they have this kind of names? Because you see you have theta here, so opposite of theta is this side. Okay, this is the reason why this side is opposite side, and sin theta is here, so this side is the adjacent to the theta. That's why this side is adjacent. So sin theta formula, if you write it, the relation between sin theta is opposite divided by hypotenuse. So what is the length of opposite here? Opposite is 4 and hypotenuse is 5, so this is 4 divided by 5. That means in this figure sin theta is 4 divided by 5. If you want, you can actually find out the value of angle theta equal to sin inverse 4 by 5, then you get the other things. Then cos theta will be what? So cos theta is, you see, a divided by h. A divided by h means adjacent divided by hypotenuse. Adjacent is 3, hypotenuse is 5, so this is how we get it. Then tan theta will be what? Tan theta is opposite by adjacent. Opposite is 4, adjacent is 3, so this means 4 divided by 3. From this we can write tan theta equals to 4 divided by 3 according to this figure. Now if you change the figure, basically definitely these things changes. Now we have some more, this is just only 3 trigonometric ratios is expressed in this ways. To understand the other 3, we have sin theta is actually, the sin theta equals to 1 divided by cosec theta. That means cosec theta will be what? That means cosec theta will be the opposite of sin theta, which will be 4 divided by 5 divided by 4. This is 4 divided by 5, so cosec theta will be 5 divided by 4. And there is another formula for cos theta. Cos theta is 1 divided by sec theta. Therefore sec theta will be 5 divided by 3. And there is another thing which is cot theta. Oh my god, I have written it in the opposite way. Actually I should have written it tan theta equal to 1 divided by cot theta, but both is correct. This is also correct, there is no mistake here, don't worry. So this will be 3 divided by 4. You see, so we have got 6 different trigonometric ratios here. Why this is 6? Do you have any idea? Do you guess it? Can you guess it? Why there is 6? Why not 7? Why not 4? Can you tell it? Do you see any clue here? Like why you know what, these are interesting. Like if you ask yourself why this happens this way, or why this answer is this, then you actually will get some interesting idea. Why there is 6? 1, 2, 3, 4, 5, 6. There are 6 different names: sin theta, cos theta, tan theta, cot theta, cosec theta, sec theta. Why there is 6 thing? The reason is, if you look at this, there are actually 3 numbers, and then if you write the ratio, this divided with this and this divided with this, how many we got? 2. This divided with this, and again this divided with this, total 4. Then this divided with this, and then this divided with this, total 6. This is why we need only 6 trigonometric ratios here. We don't need more, and we cannot work with less. Okay, so these are the basic very important relation between the trigonometric. These are the trigonometric ratios, and this actually illustrates the ratio of the sides of a right angle triangle. Let me tell you one very important thing, because most students actually make mistakes here. When you will use this formula and when you will use the Pythagorean theorem, sometimes you have to use this, sometimes you have to use this. Okay, in fact, if the rules is, suppose if you do not know the, let's say here it is given 8, here it is given 6. Now you don't have any angle given, no angle given. If no angle given, then you cannot use any of this formula. Okay, so angle must be given first of all. If angle is not given, then you can use this formula. Okay, if angle is not given, then you can use the Pythagorean theorem. Of course, if angle is given, then also you can use Pythagorean theorem. You can use in the both case, in this figure and in this figure, both figure you can use Pythagorean theorem. Pythagorean theorem is very strong, very elegant formula. And this trigonometric ratios you can use only if the angle is given. Another very important formula thing that you have to always keep it in mind. This theta actually defines which side is adjacent, which side is opposite. For example, if I give theta here, suppose this is the theta, many students will still say that this is the adjacent, because they think this is adjacent means base. Okay, some students knows it base, so this is the base. Most students will still think that this is the base. In fact, in this figure, this is not the base. Base is here, adjacent is here. In this figure, this is adjacent and this is opposite. Okay, so this according to for this given theta, actually adjacent and opposite always changes. Okay, so I hope this very elementary video this helps, and actually will make a lot of videos on trigonometry, because it is really engaging and it has huge depth. Okay, if you look at it. Anyway, thank you very much. I hope it helps a bit. All right, bye bye.